Hi, welcome back. Okay, so today we're going to talk about a new concept called acceleration. Why don't you answer this question real quick? Can you change your velocity without changing your speed? Pause the video, think about it, come back to me. The answer to that question is yes, because velocity isn't just how fast you're going. Remember, it's defined as speed in a certain direction. I can turn. Remember, acceleration is any change in velocity. Acceleration has a direction to it, just like velocity does. So if I'm turning, I'm accelerating in my new direction. Say I was going straight at 50 miles an hour, and then I turn left, that's my left, at 50 miles an hour. I've accelerated in the left direction. I was going 0 to the left, now I'm going 50 to the left. Turning is accelerating. I didn't change my speed, I changed my velocity, the direction part of it. The two other ways to accelerate besides turning are speeding up, which is positive acceleration, and slowing down, which is negative acceleration. Let me define that. Accelerating in the opposite direction. What do I mean? Let's say you're going 50 miles an hour to the north. How fast are you going south? Negative 50 miles an hour. Does that make sense? If I define south as my positive direction, and I'm going 50 miles per hour north, I'm going negative 50 miles an hour. Slow that down from 50 to 40. South, I'm going negative 40. I went from negative 50 to negative 40. Negative 40 is bigger than negative 50, technically, so technically I'm speeding up to the south if I slow down to the north. Get it? Good. There's an equation to acceleration. Yay, equations. That equation is change in velocity divided by time. Don't write that down yet. When we write it down with the symbols, A equals delta V over T. This delta V needs a little explaining. It's a triangle. Yes, I know it's a triangle. The triangle is the Greek letter delta. It means change in. So sit back, relax. Don't write this down. Just listen and read along with me, okay? What does it mean to have a change in velocity? It means how much did the velocity change? When velocity changes, you have a starting velocity and you have a final velocity. How fast you were going, how fast you are now going. The change is the difference between the final and the initial velocities. Difference is a math word, it means subtract. The difference is calculated by subtracting the initial velocity from the final velocity. So delta V, change in velocity, is final velocity, v sub f, minus initial velocity, v sub I. Remember that. Okay. So now I write down the acceleration equation. Now I want you to write it down with the letters. A is going to equal Vf minus Vi divided by T, because delta V is Vf minus Vi. Alright? So from here on out, in order to work that equation, we've got to make some big major assumptions to make your life easier and my life easier. Alright? We assume that nothing turns. You have to remember that turning is accelerating, but I'm never going to make you actually calculate acceleration from turning. No. We assume all motion is in a single line, speeding up, slowing down, turning around. If you really want to calculate acceleration due to change in direction, go take physics in college. I don't even do that in physics class for high school. No. Okay, a few practice problems that I can work out with you. And then you're going to work on the ones on the worksheet that came with today's lesson. Alright, problem 1. You may have the answer up there ready for you. What is the acceleration of an object that increases velocity by 12 meters per second over 3 seconds? Okay, I didn't give you a final or initial velocity this time. I gave you just what the Vf minus Vi is. It is 12. So, it's going to be change in velocity, 12, divided by time, 3, equals 4. And meters per second divided by seconds is meters per second per second. Those of you who know a little bit more about math, you know you can actually write that unit down as meters over seconds squared. Okay, great. But what does that unit even mean? Units have meanings. Units tell us stories. Let's find out. Meters per second, or meters per second squared, simply means a change in speed, in this case measured in meters per second, per every second. So an acceleration of 4 meters per second squared means that every second my speed is increasing by 4 meters per second. So if I start off at 0 and I accelerate 4 meters per second squared, for 1 second I'm going now at a speed of 4 meters per second. After 2 seconds I'm going 8 meters per second. That's right, 8. After 3 seconds I'm going 12 meters per second. I don't have 12 fingers, sorry. After 4 seconds I'm going 16 meters per second. You see how I'm just adding 4 for every second? There you go. That's all it means. Alright, problem number 2. What is the acceleration of an object that was going 20 meters per second, is now going 10 meters per second, and took 5 seconds to change its velocity? Pause, figure it out on your own, come back to me. Good, here we go. So it was going 20 meters per second, so 20 meters per second is the initial or beginning velocity because it's past tense. It is now going 10 meters per second, so that's the final velocity, and 5 seconds is the time. Final velocity 10 minus initial velocity 20 divided by the time 5. 10 minus 20 is negative 10. Did you forget to make it negative? You probably did 20 minus 10, didn't you? If you didn't, good job. If you did, hey, now you know better. Don't worry about it. Negative 10 divided by 5 is negative 2 meters per second squared. How can you have negative acceleration? We talked about that. All that means is you're slowing down. Every second, the velocity decreases by 2 meters per second. That's all it means. Problem 3. A plane starts off at rest and 30 seconds later reaches a takeoff velocity of 270 meters per second. I'll wait for you. Don't forget to pause. Okay, back from pausing. So if a plane starts off at rest, that's actually a number. At rest means 0, not moving. 30 seconds later is your time. 270 meters per second is your final velocity because it later reaches a takeoff velocity of 270 meters per second. Later means the final velocity. So the plane's acceleration is going to be final velocity, 270, minus initial velocity, 0, divided by 30, which is 9 meters per second squared. That's it for today's lesson. It's a new equation. Now, print out, if you can, the worksheets. If not, work them on a piece of paper. Get those answers done, and I'll post answers tomorrow. Okay? Bye.